Numbers, probabilities, predictions. Does it all sound like a whirlwind of complexity? Not anymore. Naive Bayes is here to save the day, and trust me, it's simpler than you think. Welcome to day 12 of the 30 Days of Machine Learning series. New here? No problem. Click right here to catch up on the full playlist, and while you're at it, hit that subscribe button so you don't miss out on the rest of this journey. In this video, we're exploring the magic of Naive Bayes, a fast and efficient algorithm for classification tasks, from spam detection to sentiment analysis. This algorithm is a game changer. So, whether you're a complete beginner or just looking for a clear explanation, stick around. By the end, you'll see why Naive Bayes is a must-have tool in your machine learning toolkit. Let's dive in. We start by importing pandas for data handling and NumPy for numerical operations effortlessly. We load the spam.csv dataset using pandas and display its first 5 rows instantly. Let's count how many messages are spam and how many are not spam. Adding a new column to label messages. 1 for spam, 0 for not spam. Checking the shape of the data and revisiting the first few rows for clarity. Now we divide the data into training and testing sets. We'll use 80% for training and 20% for testing, which ensures we have enough data to evaluate our model's performance accurately. Let's quickly check the size of our training and testing datasets to ensure everything looks good. We check the type of our training data and preview the first 4 messages to inspect them. Let's check the type of our labels and preview the first 4 labels in the training set. We'll check the type of the values in our training set to understand its structure. Now we're transforming our text data into numerical format using Count Vectorizer, which converts the words into a matrix of token counts, making it ready for machine learning algorithms to process. We'll convert the sparse matrix to an array, then check the shape to see how many features we have. Let's find out which word corresponds to the feature index 1771 and explore the vocabulary. Here, we're converting the sparse matrix to a regular array and inspecting the first row's values. We're identifying the non-zero elements in the first row and checking the value at index 1771. Here, we're initializing the multinomial naive Bayes model, then fitting it with our transformed training data to learn how to classify messages as spam or not spam effectively. We're transforming the test data using the same vectorizer to maintain consistency in features. Now we use the classification report to evaluate our model's performance, comparing the predicted results with the actual labels to understand accuracy, precision, recall, and F1 score. And that's a wrap on Naive Bayes. We've seen how simple yet powerful it is for text classification. But hold on. Next up, we'll dive into logistic regression, another essential algorithm you won't want to miss. Click on the screen to continue and explore how this algorithm can boost your machine learning skills even further.